Our next presentation is going to be on the New River Gorge Bridge Rehabilitation Project. It's going to be co-presented by Billy Varney of the West Virginia DOT and Matt Lewellyn from Burgess and Niple, and he currently serves as the State Bridge Engineer for West Virginia DOT. Matt is a Senior Project Manager in Burgess and Niple's Parkersburg, West Virginia office. He's a graduate of West Virginia University, having achieved his bachelor's degree in civil engineering in 1997 and his MBA in 2001. And he's focused his career on improving and protecting the transportation infrastructure in West Virginia by completing over 100 roadway and bridge projects. Gentlemen.
Thank you and welcome everybody. It's an honor to stand up here and speak in front of so many great bridge engineers. We are tag teaming this presentation, but I'm going to really zip through my portion so Matt can get to the really cool stuff so you guys can be really entertained. A bit of an overview. I'm really just going to give you some recent projects that we've done, and Matt's going to handle it from there. So the New River Gorge Bridge, approximately 3 years for construction at about $37 million. So main span length, 1,700 feet. Some other facts, it's about 876 feet above the New River. The Southeast Bridge group went out on the catwalk last year during our meeting, and it's about 851 feet. So not quite the 876, but it still was a great trip, and I think everybody enjoyed themselves. So it was added to the National Register for Historic Structures in 2013. And anybody have any ideas of what the cost for replacement of this structure now would be? No Southeast Bridge can answer that. So roughly 10, we're guessing 10 times as much as the original construction cost. Who knows? It may be 400 million. It's all a guess. So here's a height comparison with some various structures throughout the world. I will say, driving back from Rhode Island last year, I stopped in New York City, went on the Empire State Building and the Statue of Liberty, and paid a pretty good amount to do that. But it really does not compare to the catwalk tour of the New River Gorge. Maybe I'm a little biased, but so some background on the bridge. It's a weathering steel, so de-icing is an issue. Salt spray is an issue with weathering steel. So the first 20 years of the life of the bridge, we started seeing corrosion initiated, leaking into the box members. In '98, there was a maintenance contract put out to wash and remove the salt, replace deteriorated bolts and caulk box members, and also part of that, salt. There's not allowed to put salt on the roadway within 1 mile of the end of each bridge. So what they use now is a calcium magnesium acetate, and it appears to be helping. So some more recent projects. 2010, there was a deck overlay. 2012, a rehabilitation for $3 million. And as part of those, in West Virginia, we put out 6-year inspection contracts. And just so happens in 2008 to 2014, Burgess and Niple got the contract. And I believe they also got the 2015 to 20 contract. But as part of that contract, of course, we see issues. We supplemented that contract for them to do rehabilitation plans for the 2012 rehab and the 16 rehab, which is just finished up. There were 4 bidders on that rehabilitation project, $4.3 million to $6.3 million, primarily replacing bolts. And you're going to see through the rest of the presentation a lot of the things that we did during the 2016 rehabilitation.
Okay, thank you, Billy. To ditto what he said, it's a big honor to be here in front of you all today. Just to be at this conference, it's really humbling. Just going to walk you through the structural model of the New River Gorge Bridge. It does have a concrete deck and longitudinal stringers that, see if I can get this pointer to work. It has longitudinal stringers that run this way and takes the load to the transverse floor beam trusses, and then the load spans between the bents on longitudinal deck trusses. So the bents themselves, there's 2 kinds. There's approach bents that come down and are founded on large concrete pedestals, and then spandrel bents that come down and bear on to the arch. The arch itself is comprised of upper and lower chord members. Some people call these ribs as well. And then diagonals and posts. There's some bracing in here, but then it goes down to very large concrete blocks that are called skewbacks. So this is a video that was put together by the German film company Maximus Films. They came out to the bridge and just videotaped us during the inspection and the rehabilitation. This is part of a documentary that's called The World's Most Extreme Bridges. It's never aired in the U.S. that I know of, but we'll go ahead and let the volume play on that now.
In any case, definitely one of the most spectacular steel bridges in the world. Yet another one is located in North America, 267 meters over the New River Gorge in the state of West Virginia. Another true steel giant, the New River Gorge Bridge. The New River Gorge Bridge is located in the east of the USA, in West Virginia. Up to 20,000 vehicles rush over the steel arch bridge daily. And that makes it a maintenance monster. Cold, constant winds and its gigantic height requires the maintenance team to give their all. Minus 30 degrees is not uncommon during West Virginia winters. The river in the gorge and the remoteness of the national park means maintenance work resembles an almost logistical masterpiece. Every 2 years, a maintenance team moves in. Matthew Lewellyn and his men climb the highest bridges in the country. The New River Gorge is next.
You get more used to it as time goes on, but you know the conditions are already different. A lot of times you get a little bit of wind like we're getting right now. That can affect how your descent goes. It can move you off the steel a little bit. So the calmer, the better. So the more wind, sometimes we won't rappel if it gets too windy.
No easy conditions for Matt's protege, Andrew. It's his turn to descend first today. Although he has climbing experience, the New River Gorge Bridge is new to him.
You know what? You got as much as you can.
No one climbs over the railing without supervision. At least 2 colleagues keep their eyes on Andrew at all times. Supervisor Matt has been doing the job for 20 years. He immediately notices when something is wrong.
Got it?
Getting tired?
Yeah, with this 200 pounds of rope here, it makes it a little harder.
Descending for the first time down the New River Gorge. The rookie's tension is palpable. Today's job, by design, is a simple start. First task, superficial visual inspection. Every nook and cranny has to be controlled and documented. Andrew notes the bridge's condition on his tablet.
And he returns. What'd you see down there, boss?
Looks pretty good, Matt.
Yeah. All right.
Okay, so while I was down there, I just saw some moderate surface corrosion, a little bit of rust initiating in some of the connections. Nothing major, it's just something we'll monitor for the next inspection to make sure it doesn't get any worse.
The team's most difficult task is still ahead. Later, they have to move 2 of the bridge's metal plates, nearly 300 feet above the canyon, just below the 162-ton road. Sooner or later, the New River Gorge pushes each worker to the limit, at most when exposed to the wind.
The wind's the worst. It's always blowing here, never stops, it seems like.
Okay, got anybody that's ready to go Rappelling on New River Gorge, we need a few good inspectors. I got some people raising their hand in the back. Or if you're not into rappelling, maybe you'll stand in a spider basket. That's how we access the arch. Is with a 5/16 cable that's spooled up and down. You have a backup rope. Allows us to get really good access to these handholds that we'll look at more in a little bit. We also supplement that with rope access as well. Some things you might see if you're on inspection is a peregrine falcon. They're nesting in the lower arch bracing. We had to work around that during the rehabilitation to time that around the nesting season for the falcons. You might also see a biplane, and you might also see a biplane that flies underneath of the bridge. So you got to watch out for that. I was out there one time and had that happen. Learned to keep our ropes very short just in case a plane flies under. Billy mentioned the catwalk tours. If you have $80, you can cross over underneath of the bridge. You can be fitted up in a harness, and it's been retrofitted to have a safety line all the way across, even though you're on the catwalk. A lot of great things to do in the New River Gorge Bridge area. Rock climbing, zip lining, whitewater rafting. If you ever make it to West Virginia, go see this bridge. The preservation piece of this, the weathering steel, we all know that weathering steel is not good in prolonged wetted conditions. So one of the problems we have out here is pigeon nesting. And with that pigeon nesting, you get the moisture. And eventually, with weathering steel, it's going to lead to corrosion and possibly through-holing. Another problem is pack rust, where we have poor bolt sealing and then the nut loss. So to take a closer look at this, here's one of those situations where the bolts are just too far away from the edge of the steel, and that pack rust set in. So what we do is we come in with a product that's a penetrant sealer and wet that edge. And you can think of the penetrant sealer sort of like a WD-40 that wicks back into that pack rusted seam and then sets up like a sealer, and it just displaces the moisture. We also, in this situation, caulked over top of that to really make sure that it wouldn't have a problem in the future. We use that same product inside the handhole where that debris was built up, and the beauty of this is you don't have to do as good a job cleaning it. You can pressure wash it or just hand tool clean it and then apply the penetrant sealer. So that was the 2012 rehab. It focused on the deck truss. And once we got that done, we wanted to make sure that the pigeons wouldn't get back in there and cause the same problems in the future. And WVDOT challenged us as a company to come up with a solution that would keep the bridge keep the bridge protected long-term from the birds. And what we came up with is a magnetic bird screen. We ended up patenting this device. We installed about 1,200 of them on New River Gorge Bridge, and they've really been performing quite well. Cost a lot less than metal screens. If you can imagine going out every inspection cycle to access these locations with a metal bird screen installed and have to take out the bolts and remove those, hire a contractor to do that. There's a significant cost savings in comparing to doing cleaning costs maybe on a periodic basis. So we are taking this to a few other bridges, and we've done that with WVDOT, and we're looking to take that outside of West Virginia. So if anybody has a good application for a magnetic bird screen, then let me know. There were a few flyers on the table when you came in. So that's something that we're doing just to provide additional value. The load rating of this bridge was a 3D finite element model using Midas software. There's a whole truckload of shop drawings that we had to look through to load rate almost 5,000 members. We not only looked at vertical forces, but we looked at wind and thermal forces as well. And then in West Virginia, it's coal mining, so we have these special coal trucks that we needed to look at as well. It was really quite a bit of work. So if you look at these gusset plates, they're very large and complex. This is an inspector's head here. So you can see that we needed to have an efficient system for gathering data and have consistency throughout the project. As a result of all this analysis, we needed to strengthen a few deck truss diagonals in compression. So we just sandwiched them with a few angles over here to increase the radius of gyration. I like to say that this project has all the ingredients of a good bridge rehabilitation project. not only does it have clearing and grubbing and concrete work, but there's steel work and cleaning and painting and jacking and all kinds of fun stuff in there. So it's all in there, right? So let's dig into a few of these repairs. This is just after the contractor got on the site. We went out and did a just-in-time inspection of all the concrete surfaces out there, did 100% sounding, delineated all the repair areas with paint, and gave the contractor head-on photographs of what those repair areas were. Had really good success with this. There was no debating over what should be repaired and what shouldn't. So the finished product you can see is all the patches are done, all the cracks are sealed, and it's coated with a nice epoxy coating. Looks really good. One of the big repairs we had to do, like the previous rehab focused on the deck truss. This one focused more on the arch and the bents, and right in the top of these connections, there's these hand holes. And you can see where it makes a perfect little bird box. It's good for our workers to get in here and tighten the nuts, but it's a perfect little bird box. So you can see the debris accumulating in there, and the section loss starting in the bottom of the bents where debris goes down in the bottom of them. So we know we needed to clean and seal all of that. The good news is that it didn't control the load rating. All this loss, we looked at it, didn't control the load rating, but we needed to clean all that up and just keep it protected so it didn't get any worse loss, so it wouldn't control in the future. So one of the ways we did that was just looked at how we can keep the water out, you know. And if you're out on inspection and it rains, you can see just the water flowing down the underside of this upper rib, and it just pours into the connection. So we thought, well, how about a drip bar? We put those on new bridges, right? Well, it's kind of hard to get down there and do that much welding. We don't like to weld on bridges, so we thought about what about using a magnet, and that's ended up what we went with. We also caulked it into place, so we have a high-strength magnet that's caulked into place, and those are working out really well. Another problem we had was just trying to keep the birds from coming into the top. Not only is that handhole down in this area, there's also an open end on the top, so we needed to cap that off so the birds in the water and debris couldn't fall in there. So yeah, you could use something like steel to cap that off, but what about something more lightweight, like high-density polyethylene plates? So we took those, presented that to the contractor. He was able to basically field fabricate all of those to match in those locations, and took it to the next level and was able to install that plate material throughout the structure in places where there was some water ponding. Basically use woodworking tools to make that happen, and then they're caulked into place, and also tie wired too, so that if the caulking would fail, they're not going to fall. This one's really simple. The weep hole's too high above the diaphragm so the water can't drain out. What do? You extend the weep hole to the top of the diaphragm. This is what it looks like. It's really not that much work to get a little bit of extra protection there and get the moisture out. So I don't know how many Karate Kid fans there are in the room, but I always like Karate Kid. I like the part where Mr. Miyagi tells Daniel-san, "I'll wax on and wax off," right? So that's what we did on the Gorge Bridge, was we waxed on. We knew that the penetrant sealer wasn't good, exposed to UV rays, so we needed a top coat, so we worked with WV-DOT to come up with that product, and they ended up approving this wax coating, and there's two different materials that are on the approved list in West Virginia to use. So this went really well, and you can see the finished product here with wax coating back in some of these areas. This is the penetrant sealer and the caulking inside penetrant sealer. This is at the bottom of the bench. This is where you can really see that wax and what it looked like when it was done, matched up with the existing surface really well. That tape came off. It's just blue tape. And then penetrant sealer and the base of the columns as well. Something that surprised us is the way that the contractor decided to access the bridge. Instead of having a floating platform all the way across underneath the arch, you can almost see the ropes here. They use spider baskets just like we do the inspection. And this was challenging just because you had to have an inspector there after they came up, and you had to get the timing right. So it was really labor intensive for the inspection. And B&M was on site to help the DOH with that and get to some of these extreme access locations, which worked out pretty well. We also had leaking deck joints like you have on every bridge. We decided to use the expanding polyurethane foam joints. And these go in really easy and fast. They're easy to replace in the future, so that's why they were selected. We elected to do metallization of the armor angles here. And I like to say that deck repairs are really simple. You can see here we have did the same thing where we marked out the deck, repair areas. This guy, he came through with his saw. Plunge cut in there on those marks, and then another guy came through, jackhammered it out. And then we have the finished repair here. So pretty simple process. So this is a video from that same documentary that just documents the most significant repair on the project, which was the bearing slide.
The bridge is extremely maintenance intensive, and different teams are regularly deployed. Matt and his engineers get ready for the main task of the day, under the lane directly over the canyon. The only safeguard, a loose rope attached to the foot of the bridge. After several visual inspections, the day's biggest challenge is up. A support element of the bridge must be shifted without disrupting traffic. Sounds impossible, but it is not.
Make sure you clear the guide. Yeah. About 8 or so. You're right. Move 3 3/4 of an inch.
Yeah, I agree with your mark.
Okay.
So we'll just get that mark to come over and line up with that, and we should be good.
Okay.
The middle part of the bridge expands or contracts depending on the temperature. One of the gears that ensures the necessary clearance is stuck and must be brought into position.
That's what we want. That's what we want. We want to see it move. That means it's broke loose from the vent, and we shouldn't have any problem sliding it on over.
51 exactly.
51.
Hey, John.
The pressure from the compressor supports the men and takes weight off the plate. That's how the bridge bearing is able to move and can be put back in place again. The amount of pressure, the selection and positioning of the devices are the true test of whether Andrew's calculations are correct.
Yeah, I'm happy with it.
Everything went good. Right over where it needs to be.
Yeah, everything went right according to plan. Moved it about 3 1/4 inches. And you can see our 2 marks are lined up now, so it's in the right place.
Everything fits perfectly. The bridge bearing and the supporting element are positioned perfectly again. While maintenance work was happening under the bridge, the 4-lane traffic flowed smoothly above. Daily routine on the New River Gorge Bridge, one of the most spectacular steel bridges in the world.
Okay, so what did we just see? The video is not technically accurate everywhere, so don't hold me accountable to that. There is excessive tilt in this bearing. It's overexpanded, and it's gotten this position with the center of the sole plate not lining up with the center of the base plate. And also this retainer plate is only attached through this center pin, and that has allowed independent rotation of the bolster where it has slipped on these plates. Another view of it here, you can just see that center pin. Originally it was designed to have bolts that went through these retainer plates and the gears and attach it rigidly to that bolster, but that didn't happen. So that's really what's happened over time, is that's just worked its way out of position. So we know we needed to fix this because it was approaching the limits of its safe range. So we started looking at vertical jacking. It's 400 feet up. There's no way you can put false work in. Steel bent caps, we get concerned about eccentricity. So we had done sliding before, and we thought this would be a good application for it. It's a little bit larger scale than what we had done, but we thought this could really work out and save the client a lot of money. So this is just a schematic of what it looks like. So initially what we had to do is come in and air arc off the welds on the base plate and install the jacking assembly, which composed of some thread bars that go clear through, and then just this vertical post here as well. A pushing beam, and then the jack is here. Next step's just to remove those retainer plates and allow free rotation. Then we apply the jacking force, and that is what we saw in the video, was kind of that pop or breaking loose from those welds where they were air arced off. So that gets that base plate back into position, but the roller is still tilted. So what do we do then? Very similar fashion, we have what's called a roller jacking assembly. We install it and apply the jacking force in a similar fashion, and it just pulls that roller back into place. Well, it's still tilted. We don't have the top of it quite right either. How are we going to fix that? Take that same assembly, flip it upside down, do the same thing, pull it back into place as well. So got nice economy of scale there, being able to use this in all 4 locations across the bridge using the same assembly. So now it's all plumbed up, it's good to go. We install the retainer plate, everybody goes home, we're happy with that, right? Well, not quite. We want to make sure it doesn't happen again in the future, so we install these tabs and these bars, 1x3 bars, just to lock it into place so that those plates can't get out of whack again. So we also provided a QA/QC inspection and did a sweep of the whole bridge before the contractor left the site, and we think this was really a good value to the public. This is one of the most significant, unique structures in the world. Just due to its sheer size and magnitude, it presents many technical challenges. We like to think it was a successful partnership between WVDOT and us and the contractor that was on the project. We came up with many practical solutions using innovative materials just to help protect this huge public investment for many years into the future. So with that, I'd like to just open it up to any questions that you guys might have.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.